Let's talk about the use of the static keyword in C#. Here we are in Visual Studio, and let's add a class to a project. And that class will represent a car. And so here's my class. Every time I create an object of this class, I want to be able to stamp that specific object with a serial number indicating the order in which it was created. So going back to main, it would be something simple like, and of course that object, in this case Pacer, should have a unique serial number associated with it. So I would want to be able to, say, display that. Now, of course, that doesn't exist right now, so obviously I would need to go into car and create it. So it's an int, and that would have to be public, and I called it serial number. And as we've seen before, I don't want to make that a field. I want to make that a property. There's my backing field in this case, underscore serial number. So now let's consider what that should look like. And of course, being a field, it would be private. And it's an int. And it's called underscore serial number. And to start off with, we'll say it's equal to 0. In other words, when you don't have any cars, then the serial number is 0. All right, so that implies that I'm going to want to change the serial number when we create a new car. So that would be a constructor. And we don't really need to specify the serial number because the whole point of this is that the serial number is based on the order in which the cars were created. So what I would want to do is I'd want to increment the serial number every time a car is created. So that seems to make a certain amount of logical sense. You create a new car. There's a field called serial number which is initialized to 0. You increment that to 1. And so I would then be able to return that value as part of my public property. All right, so let's see how far we've gotten. I run the code. And it says 1. Okay, so far so good. I've got one car, its serial number is 1, so everybody's happy. Now let's create another car. And print out its serial number. Like so. We'll put a little more detail in here just to make it more clear. And run that code. So Pacer is serial number 1, check. Javelin is also serial number 1. Okay, so that's clearly not what I want. In other words, every time I create a new car, I'm going to get the same serial number, and that's going to be serial number 1. So I need to fix this problem. So if we go back and look at car, we can actually see what's happening here. Every time you create a car, you get a new copy of serial number, which is then set to 0, and its value, that's to say the serial number of a given car, is then incremented from 0 to 1. So all cars would have the same serial number. So what I need is not a field that each object gets its own copy of. I need a field that all objects would share. And that's essentially what a static field is. So if I change this from private int to private static int, what this says is all objects of this class will share one copy of any static fields that they have. So now there's only one serial number field, and it's shared amongst all the objects. So let's see what that looks like. All right, now Pacer is serial number 1, and Javelin is serial number 2. So now we appear to be getting what we want. In other words, the serial number is getting properly incremented to the next value. However, if we were to go back to the Pacer serial number and repeat the output statement and rerun the code, you'll see that we still have a problem. In other words, the Pacer serial number is 1. That's true as long as we don't create another car. And then Javelin serial number is 2, and that's true as long as we don't create another car. The problem is that now the Pacer serial number is serial number 2 because they all share the same serial number. So clearly we do need a field that is unique to each object, but we also need information that's outside of any object. In other words, that's shared by all objects of the class. So how are we going to do that? So let's revisit car, and let's revisit the fact that we do in fact want the serial number of a car to be unique to that car and no other car. So I do want to make that a non-static field. And in fact, now that we have an appreciation for it, rather than saying it's non-static, we would say that such a field is an instance field. So an instance field, which is basically all the fields we've seen up until this point, is a situation where every time you create an object, you get another copy of that field. So then the question is, what would the static field be? And of course, it's still going to be private. It's an int, and let's call it next serial. And let's initialize that to 0. And in my constructor, I will set serial number plus plus underscore next serial number. In other words, what I'm saying here is that next serial number will start off at 0. And then when you construct a car, you will increment next serial number to be, in the first case, 1. And then you will assign 1 to serial number. And then when you do that the next time, next serial number, since it's outside of any object of the class, will have the value 1. It gets incremented to 2, and then 2 is assigned to serial number for the car in question. But of course, in order for that to work, we only want 1 copy of next serial number, and so we make it static. And we see the code. And now Pacer has a serial number 1. This is good. Javelin has a serial number 2. That's good. And if we re-examine the serial number of Pacer, we see that it is still 1. All right, so in other words, there was information outside of any object of the class, which is to say what the value of the next serial number for a car would be, and there was information associated with each individual object, which is to say the serial number of that object. So again, if you have a static field, it means you only have 1 copy of that field to share among all of the objects that are associated with that class. And in some ways, that's all that static is, but it can be used with properties and methods as well. So for example, let's say that what we would like to do is we would like to know what the next serial number available is at any time during the run of our code. So we don't want to make our field next serial number public, but we might want to associate it with a property, like total cars created. And it would simply return next serial number. So let's put that into main. And we'll do that after we create the first car, and then we'll do that at the very end. And so we'd expect, of course, different answers because the number of cars created at different times during the program is going to be different. Let's find out what it does. And so you see the total number of cars just created is 1 because I just created the Pacer. Serial number of Pacer is 1. Serial number of Javelin is 2. Serial number of Pacer is still 1. But at that point, the total number of cars created is 2. So it's working correctly. However, there's something to be considered. And to illustrate what that is, let's go back to program and consider that in order to get the information about the total number of cars created, I actually had to ask an object. But we've already established that the total number of cars created is a piece of data that is distinct from any particular object. So why am I going to an object, in this case Pacer, to ask that question? Another way to see this is imagine that we move this code from here or in fact we'll just copy it, to the beginning of the program. In other words, before any number of cars are created. So the problem, of course, is there are no cars created, and so we cannot specify a car to tell us how many cars have been created. And I think we can agree that the total number of cars created should be a knowable fact, A, before you create a car or any object of the class, and B, irrespective of any particular object. And so if we go back to car and we look at this property, we see that the only data that's being accessed is itself static. And so we mark the property itself as static. And this has some important ramifications. If we go back to program, we see that all the references to the static property no longer work because they're not associated with any particular instance of the property. But even more importantly, we can access total cars created without using or needing to create an object of the class. So now, instead of saying pacer, we say car. And of course, we need to make that change in any place where we have accessed that property. Like so. And now we run the code. And it does what it did before, except now it works better in that we can know when we don't have any cars, and we don't need to create an object of a class in order to ask how many objects of that class there are. Now the same mechanism applies to static methods as well. So for example, imagine we have a method, in this case called reorder, and it really doesn't matter what it does or how it works. The point is that the only data that it accesses to do its job is static data. So if that's the case, then again, we don't need an object of the class in order to execute the code. So we can make the method itself static, like so. And then when you go to access reorder as a method, you would not use an instance of the class, but you'd use the car itself. So if we went back to main and we wanted to call reorder, we would not say pacer or javelin, we would say car.reorder. So what we're seeing here is that, so if you have a static method, that method can only access other static members, static fields, static methods, or static properties. So for example, inside of reorder, if I had attempted to access serial number, as you can see, it doesn't show up in the list. I'm not allowed to do that. On the other hand, if I have an instance method, it can access static properties or instance properties. So in other words, the only restriction is on static things. So why would you want to use static things? Again, because you might want to access a method or a property that does not require the creation of an object. So when we say a static member can only access other static members, what we're really saying is that static methods and static properties have no this reference. There is no current object, therefore they aren't able to use the this keyword. For example, if I were to attempt it here, this dot, I just get a syntax error. Now let's consider the possibility that we need to initialize our static fields. So here I have a static field and I'm initializing it to 0. So that's pretty straightforward. What if I wanted to initialize that inside of a constructor? Now it could be that this is a more complicated expression than just the literal 0, but the effect is the same. What would that look like? Well, I could put that information inside of my constructor, like so. And now if you run the code, we see that every time you create a car, that static field is being reset back to 0. So clearly, initializing a static field inside of a constructor is not going to be what I want. But now that we have an appreciation for the fact that there are static fields and there are non-static fields, or that is to say instance fields, the other kind of fields, we can do the same thing with constructors, and we see that this is not a constructor, it is an instance constructor. We just never needed to call it that before because that was the only kind of constructor we had. So now let's consider what would be inside of our static constructor. So the first thing you're going to notice about the syntax with static constructors is they don't have an access type. By definition, a static constructor is public. I do want to use the keyword static, and as before, the name of the constructor is the same as the name of the class. Static constructors never take parameters, and so that's going to be empty. And then the body of the code, and then this is where I could initialize my next serial number. And just to be different, let's say that I want to start at serial number 1000. Let's say I want to, for whatever reason, reserve the first 1000 serial numbers. So now, of course, I would take this line out of my instance constructor because I only want my static properties to be initialized inside of my static constructor. So you see somewhat different syntax again. There's no access specifier, then the keyword static, then the name of the class. There's never any parameters, and then the code is only going to be accessing static fields or static methods or static properties as you see fit. Now let's make a slight adjustment to the code to allow for the fact that my serial numbers don't start at 0 anymore, but start at 1000. So in fact, let's throw a constant in here. And subtract that from my next serial number, thereby giving me the correct number of cars created. Another thing that's different about the static constructor is you will never see it called. So if I go back to main, you're not going to see a reference to the static constructor. So where is that static constructor being called? That's basically being called right here, or that is to say, it's being called the moment before it's needed. So as soon as anything references the car class that would require the need of the static constructor to take place, then that static constructor code will be called. So you're not going to actually see it in your code, but now when I run this code, and as you can see, it's behaving as we might expect. So we start off with 0 cars, then we create one. The serial number of that car is 1001. And the next one's 1002. The first one's still 1001. The number of cars is 2. And that's the use of static inside of C#.